Here is something that would have seemed absurd 2 years ago. Leptos and Dioxus, both Rust front-end frameworks running in WebAssembly, are now faster in browser benchmarks than React. Not slightly faster. Significantly faster. Both land close to vanilla JavaScript performance despite going through the Rust to WebAssembly compilation pipeline and running inside the browser's WASM sandbox. And Dioxus just got Y Combinator backing and is running in production at Airbus and the European Space Agency. The Rust front-end ecosystem in 2026 is not an experiment anymore. It is production-ready, and it is genuinely competitive with the JavaScript frameworks that have dominated front-end development for a decade. So in this video I want to give you a real comparison of the 3 major Rust front-end frameworks, Leptos, U, and Dioxus. We will build the same counter and fetch component in all 3, so you can see how each one actually feels to write, compare their rendering models, look at SSR support, and give you an honest answer about which one to use depending on what you are building. We use Leptos a lot on this channel. It is the foundation of the Gupti series and the Spanda portfolio. But I am going to be honest about all 3. Let's go. Before we dive in, I want to talk about Aarambh Dev Hub's partner, CodeCrafters, and this one I actually mean it when I say it is a good one. If you have been watching Aarambh Dev Hub for a while, you already know that we are all about understanding how things actually work under the hood. Not just using tools, but truly understanding them. Why does Redis work the way it does? How does Git actually store your commits? What is really happening when you type a command in your shell? CodeCrafters is built around exactly that same curiosity. CodeCrafters is a platform where you rebuild real developer tools from scratch. Things like Git, Redis, a shell, an HTTP server, a DNS server, a BitTorrent client, you actually build them yourself, stage by stage, in your own language. Every stage unlocks the next, and you can see exactly how far along you are as you go. Now the most popular language on CodeCrafters is Rust, and that makes total sense for this channel. If you're just getting started with Rust and want to learn it the right way, this is honestly one of the best approaches out there. Instead of reading theory or doing small exercises that go nowhere, you sit down and build something real. Something you have actually heard of. Something that exists in the real world. And that is when Rust really starts to click. This is not your typical tutorial platform where you just watch someone else code and feel like you learned something. You are the one writing the code. You are the one debugging it. You are the one making it pass each stage. That kind of active, hands-on learning is what actually makes you a better systems programmer, and I will be honest. It is genuinely a lot of fun. The challenges are used by engineers at companies like Google, Meta, and Shopify. And if your company has a learning and development budget, there is a very good chance CodeCrafters is covered under it, meaning it could cost you absolutely nothing out of pocket. Worth checking with your manager before you pay yourself. The link is in the description below. Check it out, and if you do sign up through it, you also directly support Aarambh Dev Hub, so thank you in advance if you do. Alright, now let us get into the video. Before we write any code, I want to give you the mental model that makes the rest of this comparison make sense, because Leptos, U, and Dioxus made fundamentally different decisions about how UIs should update. U uses a virtual DOM. This is the same approach React made famous. When state changes, U builds a virtual representation of what the UI should look like, compares it to the previous virtual representation, finds the differences, and applies just those differences to the real DOM. It is a well-understood model. If you have written React, the mental model transfers almost directly. The trade-off is that every state change involves this diffing computation, which adds overhead proportional to the complexity of your component tree. Leptos uses fine-grained reactivity, the same model as Solid.js in the JavaScript world. There is no virtual DOM. Instead, Leptos tracks exactly which pieces of state each DOM node depends on. When state changes, only the DOM nodes that actually depend on that specific piece of state update. Nothing else runs. No diffing, no tree walking, no unnecessary re-renders. For UIs with frequent localized updates, counters, real-time data, animations, this is dramatically more efficient. Dioxus uses a virtual DOM too, but with a custom fiber-like architecture that batches updates intelligently and minimizes actual DOM operations. It sits between Leptos' surgical precision and U's comprehensive diffing. But Dioxus's defining feature is not the rendering model, it is cross-platform reach. The same Dioxus component code runs as a web app, a desktop app on Windows, macOS, and Linux, a mobile app on Android and iOS, and even a terminal UI. No other Rust front-end framework does this. These three philosophical differences, virtual DOM with React familiarity, fine-grained reactivity with maximum web performance, and cross-platform from a single codebase, are what the whole comparison comes down to. Quick one, if you're finding this comparison useful, hit the like button. It genuinely helps this video reach more Rust developers. Subscribe for more deep dive Rust content every week. Back to the code. Let me start with you because it is the oldest of the three and the one most familiar to developers coming from React. Version 0.21, the current stable release. Set up the project. You need the WASM 32 unknown target and trunk. Cargo TOML. U version 0.21 with the CSR feature enables client-side rendering. GlueNet is the network request library for U applications. It wraps the browser's fetch API in a Rust-friendly interface. Create src main mrs. Let me walk through the U-specific patterns. The function component attribute macro creates a component from a regular Rust function. This is the same mental model as React functional components. The function returns HTML use type for virtual DOM nodes. Use state is use hook for local component state, directly equivalent to React's gstates. The state variable count is a useState handle, which you dereference with the star operator to get the value, and call setOn to update it. The callback from pattern creates event handlers. We clone the state handle into the closure because closures need to own their captures. This clone pattern feels verbose if you are coming from React, but it is explicit. You see exactly what each callback captures. The HTML macro is useJSX equivalent. It generates virtual DOM nodes. The if syntax inside HTML for conditional rendering and for iterators for lists are clean and readable. This is the part of U that feels most familiar to React developers. Spawn local from WASM Bayesian futures is how you run async code in response to an event. The browser environment is single-threaded, there are no OS threads, so you spawn a local task that runs on the browser's event loop. This is the pattern for all async operations in U. Run it with trunk serve open. Now the same component in Leptos. This is the framework we use in the Gupti series if you have been following along. Cargo TOML. src mained mitnar rs. Let me explain what is fundamentally different from U. The signal function returns a getter and a setter, a read signal and a write signal. Leptos tracks which parts of the DOM read each signal. When you call setCountUpdate or setCountSet, only the DOM nodes that read count re-render. In our counter, only the paragraph showing the count updates. The buttons, the heading, everything else stays completely unchanged. Not re-rendered, not diffed, literally not touched. This is why Leptos is faster for granular updates. Look at the view macro more carefully. String literals need to be in quotes, counter, plus, because the macro distinguishes between Rust expressions and static strings. The count expression in the paragraph is a reactive read. Every time count changes, that specific text node updates. Nothing else. The action type is Leptos's way of handling async operations in response to events. It is cleaner than use spawn local pattern. You define the async function once, dispatch it from event handlers, and read the result reactively. The suspense component shows the fallback while the action is running and shows the result when it completes. Part 6. The component attribute on the function and interview return type are the Leptos equivalents of use function component and HTML. The patterns are different enough that you will need to adjust your mental model, but the concepts map across. Now Dioxus. And this one has a different hook, because Dioxus is not just a web framework. Cargo TOML. The web feature here, you could change this to desktop and get a native desktop app. Change it to mobile and you get a mobile app. The component code stays identical. That is the promise Dioxus delivers on src mained mars. Dioxus feels the most like React of the three. UseSignal is Dioxus's reactive primitive, similar to React's useState but based on signals. You can increment it directly with count+1, which feels natural. The RSX macro uses attribute syntax with colons for HTML attributes, class, counter instead of class, equals counter. This is different from both use HTML and Leptos's view, but very readable. The spawn function is Dioxus's equivalent of spawn locale, runs an async block on the current thread. Since the signal variables can be moved into the async block and mutated there, the async data fetching pattern is clean. To target desktop instead of web, you just change the feature flag in cargo toml from web to desktop and rebuild. The component code does not change at all. That is the core of Dioxus's value proposition. If you are building a frontend in Rust and want to share what you're working on or get input on which framework to use, come join the Discord. The link is in the description. We run a weekly Sunday study group, and it is a great place to discuss these decisions with other Rust developers actively building things. Let me talk about performance with real numbers. From the JS Framework Benchmark. The most widely used browser framework benchmark, maintained at krausisgithub.io, Leptos and Dioxus both land close to vanilla JavaScript DOM performance. They significantly outperform React in every test category. U with its virtual DOM is slower than Leptos and Dioxus, but still noticeably faster than React for most operations. The reason Leptos is fastest is the fine-grained reactivity. When state changes, only the DOM nodes that depend on that state update. There is no overhead for computing what changed. Dioxus's batched virtual DOM is second, and U's comprehensive diffing is third. For SSR server-side rendering for SEO and initial load performance, Leptos has the most mature implementation. Leptos's server functions let you define functions that run on the server and are called transparently from the client. Your Leptos component can call a server function as if it were a regular async function, and Leptos handles the serialization and network call automatically. This makes full-stack Rust development genuinely ergonomic, the same Axiom backend and the same Leptos frontend, sharing types with server functions as the bridge. Dioxus added SSR support, but it is less mature than Leptos's implementation. U has SSR support as well, but the full-stack developer experience is not as integrated as Leptos. If this channel has helped you understand Rust frontend development and you want to support the work, you can buy me a coffee. The link is in the description. Every supporter makes it possible to keep building these projects and making these videos. Thank you genuinely to everyone who already has. Let me give you the clear decision framework. Use Leptos if you are building a web application and want the fastest possible Rust frontend with full-stack SSR support. Leptos is where the Rust web community is putting the most energy right now. The tooling with Cargo Leptos is excellent. The server function pattern for full-stack development is the cleanest solution in the Rust ecosystem. If you watch the Gupti series on this channel, you have already seen Leptos in a real production context. For pure web development, Leptos is the strongest choice in 2026. Use Dioxus if your application needs to run on more than just the web. Cross-platform reach from a single codebase is genuinely rare and valuable. If you are building a tool where users want both a web version and a desktop app, Dioxus solves that without two separate codebases. The Y Combinator backing and production use at Airbus and the European Space Agency give you confidence in long-term maintenance. The React-like mental model also makes it the easiest entry point for developers coming from JavaScript. Use U if your team is newer to Rust frontend and wants the most community resources, the most answered questions online, and the gentlest learning curve. U has the largest existing community, more tutorials, more Stack Overflow answers, more community examples. The virtual DOM model is a known quantity and the React familiarity is real. For teams where onboarding speed matters more than maximum performance, U's head start in community knowledge is worth something. That is the full comparison. Leptos Birdboard v0.6, U Verboard 0.21, and Dioxus Verboard 0.5 in 2026. We built the same counter and fetch component in all three, compared rendering models, fine-grained reactivity versus virtual DOM, looked at performance data, SSR maturity, and cross-platform capability, and gave you a clear decision framework. Leptos for maximum web performance and full-stack Rust. Dioxus for cross-platform reach and React familiarity. U for the most mature community and gentlest onboarding. If this video helped you decide which framework to use, hit the like button. It takes 2 seconds and genuinely helps this channel grow. Subscribe for more Rust frontend and backend content every week. Drop a comment. Which framework are you using or planning to use, and what are you building with it? I read every single one. Check out the Gupti series on this channel for a complete real application built with WASM and Leptos, and the Rust plus WebAssembly video for the foundational understanding of how these frameworks compile and run in the browser. Both are linked in the description. Come join the Discord, link in the description. And support the channel via Buy Me a Coffee, also linked. Thanks for watching and happy coding.